This is the sixth and final reference guide for Unit 6, and it deals with distance and midpoint. Distance and midpoint will be two characteristics of line segments that we'll be calculating using some nice formulas. But before we get into those formulas, it's important to cover a couple of definitions. The first term is endpoint, and the name kind of indicates what this term means. The endpoint is the point that marks the ends of a line segment. So each line segment has two endpoints. You represent your endpoints using coordinates, just as you would when identifying any point on an axis. Okay? The midpoint, again, as the name suggests, is the middle point between two line the middle point between two endpoints on a line segment. So it is the exact middle between your two endpoints. It too is written as coordinates. Both of these things have nice formulas, and we'll get into those formulas right now. So the distance formula doesn't look too nice. The distance formula is distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now this looks like an unfamiliar formula, but it's really something that you've been using for a number of years now. You've just seen it in a different way. So you've seen it as c squared equals a squared plus b squared. You've seen it written as Pythagorean theorem. And that's what this is. It's just a different way of talking about Pythagorean theorem. What I mean by that is if we wanted to find the hypotenuse of a right triangle using Pythagorean theorem, we would take the square root of a squared plus b squared. Messy there, but that's okay. The square root of a squared plus b squared will give us the length of that particular line segment, in this case the hypotenuse of a right triangle. So if we were to just draw a random line segment, let's just say that that is our line segment, and we're wondering how this ties into Pythagorean theorem. Well, let's take a look. If I wanted to find the length of that line segment using Pythagorean theorem, I would just square a, I would square b, I would add them together and take the square root of it. So if we somehow could identify the base and the vertical leg of this right triangle, well, we could use Pythagorean theorem no problem. So if our endpoints are there, well, the distance across the bottom would just be the difference in x coordinates between my endpoints. x2 minus x1 would tell us how big the base of this right triangle we created is. Likewise, y2 minus y1, well, that would tell us how tall the triangle is. It would tell us how big the vertical leg is. And now we can kind of see how all of this is tying in with the formula that's to the right. If we are using Pythagorean theorem as a squared plus b squared, and if we're saying that c is the square root of a squared plus b squared, and we're saying that the base is x2 minus x1 and the vertical leg is y2 minus y1, we can see how all of this plugs into the equation. And we can then see how finding the distance between two endpoints using this formula ties into Pythagorean theorem. Now you don't have to remember this exact manipulation or this exact rearranging or difference in representing Pythagorean theorem, but you do have to understand that the two things are related. So your distance formula that you're given, d equals the square root of x2 minus x1 squared plus y2 minus y1 squared, that comes from Pythagorean theorem. It comes from taking the square root of a squared plus b squared, or the base squared plus the vertical leg squared. So that's the first part of the distance formula that we're going to talk about, is where it comes from. The second thing I want to talk about is just a little revisitation of something from an earlier unit in this course, which is converting mixed and entire radicals. So you will oftentimes get an entire radical as your final answer. In fact, you'll always get an entire radical as your final answer when using the formula above. Sometimes you'll be able to take that entire radical and simplify it very easily. So for example, if your math spits out square root of 25, well then your distance between the two endpoints is just square root of 25, which is 5 units. But it won't always spit out a nice perfect square. Sometimes it's going to spit out something that is not a perfect square. In that case, you're given an entire radical that you will have to simplify by making a mixed radical. And if you're unsure of how to do that, we're going to do some examples on the next slide, or on the next page. And you can also revisit your notes from Unit 4 to recall how to take an entire radical and make it a mixed radical. But again, we'll be doing a couple examples of that in a minute or two. So that's how to calculate distance. There's a formula that's relatively nice that will allow you to do that. Midpoint is very straightforward. Midpoint, again, it's the middle between your two endpoints. So you're taking the average of your x-coordinates and the average of your y-coordinates, and that will give you some point that should be in the middle of both of your endpoints. So the formula is just the x-coordinates of each endpoint, x1 plus x2, divided by 2. We're taking the average of those x-coordinates. Then we put a comma because our midpoint will be a point which is represented using coordinates. And y1 plus y2 divided by 2 will give us the midpoint or the y-coordinate of the midpoint as well. So average of x-coordinates between your endpoints and the average of y-coordinates between your endpoints will give us the midpoint on the line segment that's in question. And we'll see how that works here in 1 second when we do some examples. All right, so let's look at our first problem. So line GH passes through the points G, which is at negative 4, 3, and H, which is at 6, negative 2. We're asked to calculate 3 things here. The slope, which we've done countless times, the midpoint, and the distance it covers. Now the last two, this is the first time that we'll have done it, but you'll see how the formula works once we get going. So let's start with the slope. We have done slope many, many times. So we all know that the formula for slope is y2 minus y1 over x2 minus x1. Again, it doesn't matter which you make x1, y1 or which you make x2, y2. I typically work from the right with my y2s and x2, so that's what I'll do. So we're going to go negative 2, subtract 3, and 6 subtract negative 4. So our slope, negative 2 subtract 3 is negative 5. 6 subtract negative 4, well that's 6 plus 4, which is 10. Remember to reduce. We get a slope of negative 1/2. Nothing groundbreaking there. We've done that so many times that hopefully everybody is just fine with that. Now we're asked to calculate midpoint and distance. This is where we introduce those new formulas. So midpoint, again, it's an average of your horizontal and your vertical coordinates. So when we're finding our midpoint, we're going to go negative 4 plus 6 divided by 2 for x, and 3 plus negative 2 divided by 2 for y. And when we simplify that, we find that our midpoints are 2 over 2, comma 1 over 2. And of course, 2 over 2 is not something we would leave. We know that 2 over 2 is equal to 1. So that means that our midpoint between point G and point H, it would lie at 1, comma 1/2. The average of our x-coordinates, comma the average of our y-coordinates. Now the last one that we'll do is distance. Distance has the more confusing formula, but that doesn't mean it's more confusing. It just means that it's going to get a little bit messier maybe as you're working through. So distance, x2 minus x1 squared plus y2 minus y1 squared. So now we're just going to plug in our values, and away we'll go. So x2 is 6. So 6 minus 4 squared plus minus 2 minus 3 squared. So as we work through this, 6 minus 4, well that's going to be 10. And minus 2 minus 3 is minus 5. When we square this, we get 10 squared is 100. Negative 5 squared is 25. So this gives us a distance of the square root of 125, which is an entire radical. And if you remember what was highlighted on the first page, we have to see if we can make that a mixed radical. So you go through your biggest perfect squares and see if any divide evenly into 125. 4 doesn't, 9 doesn't, 16 doesn't, 25 does. 25 goes evenly into 125. In fact, it's the biggest perfect square that does, and it goes in 5 times. So we end up getting square root of 25 times 5, which is the square root of 25 multiplied by the square root of 5. So our distance here is 5 root 5 units. Okay? There are no units given, so for distance you write u or you write out the word units. Okay? Remember that the formula will spit out an entire radical easily enough. I mean, there is a little bit tricky at times in there. But if you're careful, it will easily spit out that entire radical for you for distance. Once you have your entire radical, you have to think back to Unit 4 and see if you can make it a mixed radical or not. And if you can, you have to do that. All right, so that was question 1. We found slope, midpoint, and distance. Question 2, we're only finding the midpoint. And that's of line MN. Well, point M lies at 5, 5. And point N lies at negative 4, negative 4. Those are 2 pretty easy points to work with. So our midpoint hopefully will be not too bad to find. Let's find out. So midpoint is found using x1 plus x2 over 2, comma y1 plus y2 over 2. So now let's figure out what this gives us. So it's going to give us 5 plus negative 4 over 2, comma, and since the points are the same, for x and y, so it's 5, 5, and negative 4, it ends up being x1 plus x2 over 2 ends up being the same as y1 plus y2 over 2. And both, nicely enough, give us 1/2. So we get a midpoint that should be at about 1/2 on the x-axis, 1/2 on the y. Now we can't determine for sure that it is, but we can look at about where the midpoint would be on the graph that's provided. It would be somewhere in there. That's somewhere between the m and the n on the graph. And we're saying that based on the math we did, our midpoint would lie at 1/2, 1/2. Well, that would be right about there. And so we can see that, yeah, based on the eyeball test, that looks like it's somewhere in between m and n. So we could conclude that the work that we did to get that midpoint is probably pretty accurate. So we would be confident that our answer of 1/2, 1/2 is the right answer. Okay? So that was just a midpoint question. Now let's look at just a distance question. The town of Newton is mapped on a coordinate grid with the origin being at City Hall. So origin, of course, is 0, 0. Jill's house is at negative 2, 3, and Kyle's house is at negative 6, 9. We want to find the distance in kilometers between their houses, remembering to express that as a mixed radical. So if we just do a really quick sketch here, we can kind of see what's happening. So City Hall is at the origin, that lies right there. Jill is at negative 2, 3. So let's say that she's right about there. Kyle is at negative 6, 9, so he's somewhere over there. So essentially all that this question is doing is it's asking us to figure out the distance from J to K, given the coordinates that have been indicated in the problem itself. So given that the City Hall is at the origin, that's not really important. We don't have to do anything with 0, 0. It's just giving us kind of a bearing system that we can then associate Kyle and Jill's houses with. So here we're just finding the distance. So again, we know our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So given our coordinates here, for x, it's going to be negative 6 minus negative 2 squared plus 9 minus 3 squared. Negative 6 minus 2, it's going to be negative 4. And then 9 minus 3, of course, is 6. So when we plug all this in, we get the square root of 16 plus 36, which gives us the square root of 52. So again, we come to this point where we say, okay, we've got an entire radical. Can that be made into a mixed radical? And the way you tell is you divide all your perfect squares into 52. And if any of them work, then yes, it can become a mixed radical. So 4 will work. 4 will go in 13 times, but maybe there's a bigger one. 9 won't. 9 times 6 is 54, not 52, so it doesn't work. 16 doesn't work, and 25 doesn't work. So 4 is our biggest perfect square, but it still works, so we then have to take square root of 52 and make it a mixed radical. So we know that it's 4 times 13, so our distance is the same as square root of 4 times square root of 13, which gives us 2 root 13. So therefore, the distance between their houses is 2 root 13. And don't forget, since the question gave us very specific units, we have to include those units. If it didn't, we would just use U. But in this case, it says it's in kilometers, so the distance between their houses is 2 root 13 kilometers. Okay? And that is it for the reference guide. Your formulas will help you most of the way. With midpoint, it will just spit out the midpoint. No extra work required. Just make sure you reduce fractions if needed. With your distance formula, there is a bit of extra work required. Your formula will spit out an entire radical. The extra work is up to you to determine if that entire radical can be made into a mixed radical.